So today's lessons, we are going to learn an alternative to long division with polynomials. It's called synthetic division. So at the top of your paper, please write down synthetic division and put a Roman numeral 1 behind it. This is a two-part lesson. Today is just, bless you, today is just the basics of what is synthetic division. So synthetic division will allow us the opportunities to solve a polynomial equation and to find out what values of x would make this particular equation true. So if it exists, we know that there is a value, by the way, up to 3 real values that I could substitute in for x. And when I do that and I complete all the math on the left-hand side, we will see that it equals 0. So how do we do that? Well, first we have to understand, how does this work? We need to identify what are the possible solutions. Possible solutions does not mean these are the answer. These are the possibilities that could be the answer. So do me a favor, please, and I want you to circle the constant at the end and circle the leading coefficient. We are going to write down in the numerator, we're going to write down all the factors of 6, both the positives and the negatives. So factors of 6 would be plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6. These are all the numbers that nicely divide into 6. And when you divide it in, you get no remainder. What are the factors of 1? Only positive 1. So to achieve all the possible solutions, real solutions to this, what we would do is we would go ahead and we would divide 1 divided by 1. Well, that's 1, and it could be plus or minus. 2 divided by 1 is 2, 3 divided by 1 is 3, and 6 divided by 1 is 6. So there's 1, 2, 3, 4, 5, 6, 7, 8. There are 8 possible solutions. And now we're going to go ahead and we're going to test them. In today's lesson, everything will have a leading coefficient of a 1, which makes it really easy. So once we identify the constants and the factors of the constant, divided by 1 is not going to change anything. Okay, so I refer to synthetic division as just an acronym is the MAMA method. And the reason I refer to it as the MAMA method is because we're going to do the operations multiply and adding continuously until we are able to come up with a solution. So let's get started. Here's how this works. If I can grab a marker, we are going to make an upside down division box, and it needs to be fairly deep. And we're going to begin by testing. I'm going to start by testing positive 1. So I put a positive 1 out front. Now everything has to be accounted for. The highest exponent, referred to as the degree, is a 3. So there's a 1, and I'm really small, I'm going to write x to the third as we start to learn this. And then we have a negative 2, x squared, a negative 5, x to the first, and this positive 6 is really x to the 0. When you don't see an x there, it is x to the 0. So everything is accounted for. What does that mean again? I identified the highest exponent on a variable. There's 3, 2, 1, and 0. And now I'm going to start by dropping down the very first number. This is like a magical number, and everything's going to go back to this. So I'm going to write MAMA off to the side as a reminder of what the operations are. Okay, so once I get started here, everything is set up. I'm going to start by multiplying. What do I multiply? The bottom number with this little magical number outside that I'm testing. 1 times 1, where do I put the answer? Underneath the second set. So I've multiplied, and now I'm going to add straight down. Negative 2 plus 1 is negative 1. And I just continue this pattern. So MAMA, I'm back to M for multiplying. What do I multiply? I take this number at the bottom, and I always multiply by the magical number out front. Negative 1 times 1 is negative 1, and I add straight down. And I just continue this pattern of M-A-M-A. We're always ending on an A. Okay, so I'm down to negative 6. I always multiply to the magical number out front, which is negative 6, and I add straight down. Now, whatever we get here is the remainder. When we get a remainder of 0, it's like ding, ding, ding. It tells me that this is a solution. So off to the side, I have tested 1 and it works. I'm going to write x equals 1. This represents the possibility of real solutions. So there's possibility of 3 real solutions, and I'll tell you right now, since we have not learned about imaginary solutions, everything here will be real. So for today's lesson, we're going to come up with 3 answers. Here's one of the 3. How do I come up with the other ones? Okay, pay close attention now. We're going to write this backwards. So underneath this, please write 0 equals. Okay, and we're going to count backwards. Like this is x0, x1, x2. Hold on. Excuse me. This has no x's, so 0 x's. This has 1 x, and this has 2 x's. And if there was another number, it would have 3 x's. This is a quadratic equation, and there's multiple ways that we can solve this. If factoring is a possibility, absolutely, let's factor. If we cannot factor, we could do the quadratic formula, completing the square, other things like that. So I'm going to see, can I factor this? Okay, 1 times -6 is -6. I'm looking for two numbers, if this is factorable, that multiply to give me -6 and combine to give me a -1. That would equal -3 and +2. Let's make sure. Multiply and combine. Again, this is the longer way. It's not my preferred way of factoring, but I know that this is how you learn freshman year, so let me demonstrate again. I put down the first, and I put down the last one. In this open spot, I'm going to drop in the -3x and the +2x. Okay, so I'm factoring here. I'm asking myself, what can I factor out? I can factor out an x, and I'm left with 1x minus 3. I want to make sure I did that right. There's 1x squared, there's -3x, okay, great. 1x minus 3 equals 0. Is there a value I can take times 1x and end up with +2x? There is, +2. 2 times 1x is 2x, and 2 times -3 is -6. So in the front and back, it both contains 1x minus 3. In front of the first parentheses is x, in front of the second parentheses is +2. If I asked you to solve this, I already have one of the 3 solutions. How do I achieve the other 2? Well, I'm going to take each one of these factors, 1x minus 3. I'm going to set it equal to 0, and I'm going to solve. So I'm going to add 3 to the other side. Another solution is x equals 3, and I'm taking x plus 2, setting equal to 0. And the final solution is x equals -2. So I have 3 solutions, 1, -2, and 3. Again, 1, -2, and 3. What does that mean? We'll learn what that means on a graph later on, but I'll tell you right now, if you substitute 1 in here for x, and you completed all the math on the left-hand side, it would equal 0. If you substituted 3 for x, you completed the math. Or if you substituted -2 in for x and completed the math, they would all equal 0. And we'll see what that looks like on a graph when we come back on Monday. Example number 2, there's one thing that is different, and only one thing. Notice example number 1 has a value in front of the x to the third, to the second, to the first, and there's no x's, it's x to the 0. Everything's accounted for. But in example number 2, okay, here's x to the third, so there's a 1 out front. So x to the third, awesome, x squared, everything's there, x to the first. Do you guys see how there's no x to the 0? So we need to put plus x to the 0. Now everything is accounted for. If something's missing, we need to put a 0 in that place, like a placeholder. As a reminder, how do we get started? We're going to list all the possible solutions. I know there's going to be 3 at the end, but we need to list all the possibilities. So we're first going to circle the constant and the leading coefficient. In the numerator, I'm going to list all of the factors of 0. Well, factors of 0 is simply 0. There's no other factors. And the factors of 1 would be 1. Well, 0 divided by any number is simply 0. So let's go ahead and let's test 0. We're going to make this upside down division box and make it a little bit deeper than you'd make a division box. And we're going to test 0. Now in this place, I need to put these neatly in order. 1x to the third, -2x squared, -15x to the first, and 0x to the 0. When I test 0, if I end up with a remainder of 0, again, it's like ding, 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 this works. This number out here I just tested is a solution. I'm going to write MAMA up here, and remember you can do MA as many times as you want. MAMA is just like my acronym to remind myself I'm going to multiply and add, multiply and add. Also remember that this number that's out front is the magical number that we're always going to multiply to. So how do we get started? Before we get started, we drop down the very first number. That's our first step, drop down the first number. And now we're ready to begin. So I'm going to start by multiplying. And you're wondering, like, what do I multiply? It's the bottom times the magical number out front. 1 times 0 is 0. I put it underneath the second number. Okay, now I'm going to add straight down. -2 and 0 is -2. Time to multiply again. -2 times the magical number is 0. and I add straight down. Okay, it's time to multiply again. Negative 15 times 0 is 0, and I add straight down. How do I know with what I just did? How do I know what that, like, what does it even tell me? Whenever we get a remainder of 0 at the very end, it tells me that whatever number I tested works. So please write x equals 0. That is a solution. How many real solutions could we have? We can have up to 3, and I'm telling you that today is the first lesson. Today you will have whatever, it's right here, it's called the degree, whatever the highest exponent on the variable is, that's the number of real solutions you will have today. Now, we're going to expand that and learn more about imaginary numbers later, but for today's lesson, that's going to be a clue for you. What do I do with this? Okay, I'm going to write backwards, and we're going to count backwards. So it has no x, so no x, it has 1x, and it has 2x's. Always counting backwards, this time going from right to left. And we're now going to solve this quadratic formula. Remember, you can always solve using the quadratic equation. I prefer to see if factoring is a possibility first. So what multiplies to equal negative 15 and combines to give you a negative 2? That's going to be 5 and 3 with different signs, multiply and combine. Okay, so I'm going to come off to the side here. And remember, there's more than one way to factor trinomials. I would do it a different way than what I'm demonstrating, but I know this is the way you learned freshman year. I'm going to drop in the negative 5x and the positive 3x. Okay, so I'm going to factor out an x, and I get 1x. X times 1x is 1x squared. X times negative 5 is negative 5x. And then I'm going to copy and paste that in back. And I'm going to figure out what is this missing value here. What times 1x gives us a positive 3x? What times 1x gives us a positive 3x? That's going to be a positive 3. Let's make sure that works. There's 3x when I distribute, and here's a negative 15. In the front and the back half, they both contain a 1x minus 5. In front of the first is an x. In front of the second is a positive 3. We've done a lot of work, but we're not done. Our goal is to solve. So I'm going to take each one of these, and I'm going to set it equal to 0, each one of these factors, and I'm going to solve. One answer will be x equals 5. Another answer will be x equals negative 3. So I have 3 solutions. What are the solutions? 0, 5, and negative 3. Thumbs up or thumbs down right now, not in speed, but just understanding as I'm going through this. Okay, we're looking around about in the middle or down. Let's look right now at example number 3. Okay, let's look at example number 3. So the very first thing we're going to do is we are going to circle both the constant and we're going to circle the leading coefficient. And we're going to start by writing down and identifying what are all of the possible roots. It doesn't mean all of these are going to be solutions. Okay, so I have plus or minus 1. I'm writing down all the factors of 24. Plus or minus 2, plus or minus 3, 4 nicely divides in, 6 divides in, 8 divides in, 12 divides in, and 24 divides in. On the bottom will always be the factors of the leading coefficient. Okay, so this is a lot of numbers in order for us to test. We can see we have, when I divide, I have 2, 4, 6, 8, 10, 12, 14, 16. I have 16 different numbers to test. But as soon as I find one that works, remember I'm able then, at that point, as soon as I find one that works, I'm able to go ahead off of either using the quadratic formula or factoring in this case to solve for the other 2 remaining solutions. Let's start with 1. So let's do an upside down. Let's do an upside down. And since this is our third example, I'm going to speed it up a little bit. So I'm looking up above, and I have 1x cubed, I should write smaller, minus 5x squared, minus 2x, plus 24x is 0. The nice thing about this one is we can see that nothing was missing. So I didn't have to put a placeholder of 0 in any position. Okay, so I'm going to drop down the 1 right now, and I'm ready to do the mama method. Remember, mama method is always going to come back here. This is our magical number that we're multiplying by. 1 times 1 is 1. Add straight down to get negative 4. 1 times negative 4 is negative 4. Add straight down to get negative 6. 1 times negative 6 is negative 6. Add straight down to get 18. For those that have been here, does this represent a solution? Thumbs up, thumbs down if it does not represent a solution. Good, thumbs down means no solution. Why? Because this isn't 0. So I'm going to come over here and I'm going to cross out a 1. Doesn't work. So in some ways, this is like trial and error. We're going to do the exact same thing, and I'm going to test -1. As soon as we find one that works, we should be able to factor again or use quadratic formula to solve for the other 2 remaining. So 1x cubed minus 5x squared minus 2x plus 24x to the 0. We dropped down the 1 before we even get started, and now we're ready to start with the mama method. Remember, everything we do is going to go back to this magical number when I do mama. So mama, M for multiply, and then add straight down. Multiply and add straight down. Multiply and add straight down. Does this one work? It does not. So we are going to, as a team right now, I want all females to test right now, test +2. I want all males to test -2. Same thing. Females, which one are you testing? Are you testing positive or -2? Females. +2, okay. And males test -2. Please go ahead. Okay, so I'm going to test +2 here. So how do I test +2? Okay, everything we do is going back to this magical number. I'm dropping down the 1. I'm multiplying, I'm adding down. I'm multiplying, I'm adding down. I'm multiplying, I'm adding down. 2 does not work. Gentlemen, does -2 work? Okay, let's all try -2 right now. Can we all try -2? So even if you're a female, let's all write down -2. I'll give you more seconds to get that done, please. Okay, multiply to get -2, add down to get -7. Multiply to get 14, add down to get +12. Multiply to get -24, add down to get 0. This works. How do I know it works? Because the remainder is 0. So I'm going to put up here and write x equals -2. That's one of the solutions. Notice that in example number 3, I should have 3 solutions. 3 solutions, one of them being -2. What do I do once I find that out? Well, when we're working with the cube, it's really nice because this remainder, I can go 0 equals, and I'm going to work backwards. No x, 1x, 2x. And now let's see, can I go ahead and factor this? I don't know. If not, I'll use the quadratic formula. What multiplies equal +12 and combines equal -7. All right, let's check. I'm going to say -3 and -4. Let's make sure that works. They multiply to give us +12, and they combine to give us a -3. That does work. Okay, great. So I have 1x squared plus 12 equals 0. In these positions, I have a -3x and a -4x. And I'm going to quickly go through and factor this. Now, a lot of students show all of this work and they stop at this point. So they factor. Remember, our goal is to use synthetic division and factoring in order to actually solve. I've solved 1 solution, but I should have a total of 3 solutions. I'm going to set each one of these factors equal to 0, and I'm going to solve. And in doing so, I end up with answers of x equals 3 and x equals 4. Now, again, we're going to learn about what do these mean on a graph in an upcoming lesson. But for now, I want you to recognize that if you took -2 or 3 or 4, and you came back to this polynomial equation and you plugged those in, -3, -3, -3, and you did the math correctly, it equals 0. Or you plugged in, sorry, I should have said +3. Or if you plugged in +4 and you did the math, it should equal 0. Or if you plugged in -2 and you do the math, it should equal 0. Okay, let's go on to the next one. Here's our last example for today. Please write down example number 4. Last example for today. Now, what could really catch students up? Well, there's 2 things here. I think we're going to have to do a little more work. The first one is I see some missing pieces to this. That's the first part. The second part is that we're now going to go x to the 4th. So x to the 4th, notice there's no term that's x to the 3rd, plus 0x to the 3rd. Notice there's no term that's x to the 1st, plus 0 sorry, this should have been subtraction. I don't want you to get confused there. Plus 0x to the first plus 36 equals 0. So the first thing I did is I made sure that if there was a missing part, I filled it in with a 0. Now let's go ahead and let's circle the leading coefficient and the constant. Now I could go through and I could list all of the numbers of 36. So I'll do that, you don't have to. So there's 1, unless you came in late, maybe you should have another example. So 2 nicely divides in, I know 3 does, I know 4 does, 6 does, 9 does, 12 does, 18 does, 36 does. And then on the bottom, again, for today, it's really nice, it's only 1. So if somebody said how many possible real solutions, there's 2 here, there's 2 here, 2, 4, 6, 8, 10, 12, 14, 16, 18. There's 18 possibilities. There are 18 possibilities. Okay, we're gonna do this together. You ready? And I'm gonna time you here. Females, I want you to test +1, males test -1. And let me know if it works, or let me know if it doesn't work. Ready? Females test +1, males test -1. Begin. You know what? For time purposes, I'm even going to switch it up even. I'm going to do it even more because there's so many possibilities. So stop what you're doing real quick. Ready? I want this group up here, all of you. So sorry. I want you to test +1. So these 4 test +1. I want you 4 to test -1. I want you guys to test +2, -2. I want you to test +3. I want you to test -3. So if you are watching this video back because you are not here, we're doing this kind of as a group effort. I have 6 different groups. I've assigned one group to +1, another group to -1, one group to +2 and -2, another group to +3 and -3. And we're going to figure out, do any of those work? Please shout out if you have one that works. Chloe, what did you try? Negative what? Did it work? -1 does not work, I'm hearing. What did you try over there? Did 2 work? 2 works. Okay, I want everybody to stop for a second. We got 1 that works. Let me see here. So I have 1x to the 4th, 0x to the 3rd, -13 x squared, 0x to the 1st, and 36. And I'm going to have an answer down here. Let me check here. Let's see if Camila is right. So mama method. First I dropped on the first number before you even start the mama. So here we go. M for multiply, then add down. Multiply, and then add down. Multiply, and then add down. Multiply, and then add down. So I can see that 2 works. By the way, did anybody test -2? Did it work? Okay, so you can still get the right answer and -2 works. By the way, did anybody test 3? Did 3 work? What did you guys test? -3? Did it work? Okay, so let's go ahead right now and let's go with what I have. Now what's different right now, I need everybody to look, what's different right now is that everything up to this point would have been quadratic, but watch this. Please follow along, just pick up where you are and write what I'm writing from this point forward. 0 equals, okay, there's no x, there's 1x, there's 2x, and there's 3x. Now we don't have a quadratic equation. So in order to solve this, we got to think about other skills we've learned. We may go back and do the mama method. We may list a bunch of possibilities. So we may go back and circle, don't do it yet, but we may go ahead and circle the constant and the leading coefficient and go, okay, what goes into 18? 1, 2, 3, 6, right, 9. And we're going to test more numbers. We could do that, or I'm looking at this and I see a pattern. Do me a favor, can both of you underline this first one? I think factoring by grouping is going to work. What do I mean by that? I see 3x's here and 2x's here. Now the only number I can factor out is a 1. That's not really helping me at all, but I can take out 2x's. 1 times 1 is 1. I need 3x's. That means I need 1 more attached. 1 times +2 is +2. I need 2x's. I already have them. I'm going to copy and paste what's here in back. What value times 1x is a -9x? What times 1x is a -9x? -9. -9 times 1 is -9, and there's an x. -9 9 times 2 is negative 18. So I have a front and a back half. 1x plus 2 is in both. And then in front of the first parentheses is 1x squared. In front of the second parentheses is a negative 9. Remember, this problem was different. How was this different? How many answers should I have here, kiddos? I have 4. And I only have one that works. So I'm going to write this down. X equals 2. That's 1 so far. That's one real solution. I'm going to take each one of these parentheses, called factors, and I'm going to set it equal to 0, and I'm going to solve. So the first one is really easy. I'm subtracting 2 to the opposite side. Okay, negative 2 is another solution. Then I'm going to do the last parenthesis, called a factor. I'm going to start by adding 9 to the opposite side, taking the square root. Guess what? How many answers are we going to have? We're going to have 4 total, but at this position, what does this tell me? How many answers right here? 2. Plus or minus, and the square root of 9 is 3. So if I had to list out the solutions to this, it would be x equals 2 and negative 2 and 3 and negative 3. What does that mean now that we have not really attached this yet to a significance on a graph? It means that if I plugged in 2 for x or negative 2 or 3 or negative 3 into the left-hand side, it would equal 0.